Picture a cliff face in the middle of nowhere, sliced open by wind and time like the planet has been keeping a diary in stone. Layer after layer rises above you, each one older than cities, older than forests you would recognize, older than the bones of almost everything alive today. And in the lower layers, the rock is busy. It is crowded with clues, shells pressed flat like old coins, fragments of skeletons, trails left by bodies moving through mud that has not been mud for millions of years. It is not exactly a photograph of the past, but it feels close enough to one. A world was here. Creatures lived here. They ate, crawled, swam, hid, reproduced, died, and left just enough behind for the rocks to remember them. But then your eyes move upward, just a little, to the layers above. And suddenly, the record goes quiet. The fossils thin out. The familiar shapes vanish. The little signatures of life that seemed so common below are gone, or close to gone. It is the kind of silence that makes you want to lower your voice, even though you are standing in front of a wall of rock. Because it looks like a crime scene after the bodies have been taken away. For a paleontologist, that kind of absence can feel almost as powerful as a fossil itself. A bone says something was here. A footprint says something passed through. But an empty layer seems to whisper something much darker, something stopped. And for a long time, that whisper has been enough to build a story around. Before this point, life. After this point, disappearance. You can see why the conclusion would be tempting. Honestly, it is almost too neat. The ancient world gives you a before and an after, and our brains, being the pattern-hungry little detectives that they are, rush to fill in the middle. Something must have happened. Some disaster must have swept through. Some climate shift, some dying sea, some ecological trapdoor must have opened beneath an entire group of organisms. The case seems obvious. The victim was life, the suspect was extinction, and the rock record was the witness. Except witnesses can be unreliable. Especially when the witness is a stack of sediment that has been buried, squeezed, eroded, broken, uplifted, and exposed again after a span of time so enormous that the Grand Canyon starts to feel like recent paperwork. Still, from a distance, that empty layer is hard to ignore. Imagine standing there with a hammer in your hand, dust on your boots, and the hot wind scraping across the outcrop. Below your knees, fossils. Above your head, almost nothing. It is not hard to feel like you are looking at the edge of an ancient catastrophe. A place where one chapter of life ended so abruptly that the planet itself stopped taking notes. And that is where this story begins, not with a definition of extinction, not with a tidy textbook explanation, but with a gap. A strange, uncomfortable gap in the memory of Earth. Because gaps are dangerous things in science. They invite answers. They dare us to connect dots. And sometimes, when the dots are separated by millions of years, the line we draw between them says more about what we expect to find than what was actually there. So the question is not just, did something vanish? That would be too easy. The better question is, vanished from where? From the world itself? Or only from the rocks we happen to find? Because the fossil record is not a security camera pointed at the entire history of life. It does not record every creature, every shoreline, every swamp, every reef, every unlucky animal that failed to get buried quickly enough. It is more like a damaged archive, one that keeps some pages in astonishing detail and lets others rot away completely. Which means a missing fossil can be a clue, sure. But it can also be a trap. And in this case, that trap may have been so convincing that scientists once looked at an empty stretch of stone and saw an extinction that, maybe, never really happened. Not the way they thought. Not as cleanly. Not as finally. And if that sounds strange, good. It should. Because somewhere between the fossils that are there and the fossils that are missing, there is a mystery hiding in plain sight. When the rocks go silent, are they telling us that life ended, or are they telling us that Earth simply stopped preserving the evidence? And once you start looking at that silence in the rock, it becomes very hard to stop seeing it. Because the old story had a certain elegance to it. Too much elegance, maybe? Down in the older beds, the world seemed almost loud. The sediments were packed with the familiar remains of a community that had been doing just fine, at least from the point of view of the fossils. You could find the same kinds of hard parts again and again, scattered through the stone like repeated names in an ancient census. A shell here. A spine there. A little ridge or groove that told you an animal had once pushed through soft sediment, unaware that its ordinary afternoon would become evidence. Then, above a certain boundary, those names dropped out. Not faded slowly in a way that felt comfortable. Not replaced by an equally familiar cast. Just gone enough that the absence started to look meaningful. And meaning is exactly what scientists are trained to look for. The rocks were not just empty. They seemed organized around their emptiness. They gave the impression of a before and an after, and that is one of the most powerful shapes a story can have. Before the door closed, these creatures were part of the world. After it closed, they were not. And if you were trying to solve the case with the evidence available at the time, extinction was a pretty reasonable suspect. It had motive. It had opportunity. The history of life is full of endings, after all. Whole ecosystems have been knocked sideways by climate change, shifting seas, volcanic eruptions, falling oxygen, hungry competitors, unlucky geography, and the general fact that Earth is not exactly sentimental about keeping species around. So when the fossil record seemed to show a disappearance, the simplest answer was also the most dramatic one: something had wiped them out. But then there was the problem of how little the rocks were actually saying. They were not giving up a smoking crater, or a layer of ash that stretched across the world, or a neat line of bodies piled up like a prehistoric disaster movie. They were giving something subtler, and honestly more annoying: a pattern. A repeated absence. A vanishing act with no obvious villain standing at the scene. That is the kind of evidence that can pull scientists in two directions at once. On one hand, a pattern in the fossil record is not nothing. If a group appears in many places for a long stretch of time, and then suddenly becomes hard to find, you have to take that seriously. On the other hand, hard to find is not the same thing as dead. Ask anyone who has ever lost their car in a stadium parking lot. Scale that problem up by hundreds of millions of years, bury the parking lot under sediment, crush it into rock, erode most of it away, and then ask a graduate student with a field notebook to reconstruct the entire situation. Not so easy. And this is where the old story began to feel a little less like a verdict and a little more like a question. Because the fossils were not vanishing from every possible place. They were vanishing from the places where people had looked, from the kinds of rocks that happened to be exposed, from environments that happened to preserve some bodies and erase others. Imagine an ancient coastline sliding back and forth over thousands of years, like the edge of a blanket being pulled across a floor. A shallow sea advances, retreats, leaves behind mud, sand, shells, chemical traces, then disappears. A river changes course. A lagoon fills in. A reef dies back. A basin that once trapped life gently enough to fossilize it becomes a place where remains are broken, dissolved, scattered, or never buried at all. To us, millions of years later, that shift can look like a biological ending. But to the animals living through it, it may have felt less like the end of the world and more like the world rearranging the furniture. And then come the little details that make the case uncomfortable. A fossil found a bit higher than expected. A specimen from a region that did not fit the clean timeline. A layer once thought to be one age, then dated again and placed somewhere else. A museum drawer holding a fragment that suddenly matters more than anyone realized. None of these clues has to shout. In paleontology, sometimes the evidence that changes the story is smaller than your thumbnail. But it can still sit there, stubbornly, like a witness who refuses to match the official report. And if even one clue appears after the supposed ending, the question shifts. It is no longer just, what killed them? It becomes something much trickier. What if the disappearance was real only in the record we inherited? What if the world kept living, but the rocks stopped keeping receipts? By this point, the case seems to have two very different kinds of evidence pulling against each other. There is the grand pattern, the one you can almost see from across the outcrop. Life shows up, life becomes common, life drops away. And then there are the small, stubborn clues that refuse to behave. A fragment in the wrong layer. A shell where the silence was supposed to begin. A trace that looks like it wandered in after the curtain had already fallen. So to understand why the old story became so convincing in the first place, you have to go back to the world before the gap, when these organisms were not rare little footnotes hiding at the margins of history. They were part of the scenery. In some places, they were the scenery. Imagine a shallow ancient sea stretching toward the horizon, warm and sunlit, its floor dusted with pale sediment. The water is not empty blue space. It is busy. Animals crawl over the bottom, burrow through the mud, filter food from the current, armor themselves against neighbors that would very much like to eat them, because even deep time had rude roommates. Their hard parts settle into the seafloor after death, and layer by layer, the ecosystem leaves behind a record dense enough that millions of years later, someone can kneel in the dust, crack open a piece of rock, and find the same familiar shapes again. That kind of abundance matters. It makes a disappearance feel sharper. If a creature was always rare, its absence might not say much. But when a group is common, widespread, and easy to recognize, when it shows up across many beds like a signature written again and again, then its sudden decline becomes difficult to shrug off. It starts to look less like bad luck and more like a message. And for a long time, that message seemed clear enough: something changed, and this once visible world could not follow. The first real clues came not from a single spectacular skeleton, but from the ordinary machinery of geology. The texture of the rock. The kind of sediment. The chemical stains left behind by ancient water. The places where fossils clustered, and the places where they did not. A bed of fine mudstone can suggest quiet water, the kind of place where small shells or delicate remains might be buried gently before scavengers and currents tear them apart. A layer of coarse sand can tell a rougher story, of moving water, broken pieces, bodies dragged and scattered before they had any chance of becoming fossils. A dark, organic-rich band might hint at low oxygen, a seafloor where decay slowed and preservation improved, but where living there could have been a terrible idea if you enjoyed breathing, which, historically, many animals have. These are not just rocks. They are crime scene details. And they can tell you whether the missing fossils might reflect a dying ecosystem, or simply a change in the way the scene was recorded. But here is where the mystery gets slippery. The same geological shift that could kill some organisms could also erase evidence of the ones that survived. A sea level fall might drain the habitat of a shallow water community. Or it might just move that habitat somewhere else, onto rock layers that were never preserved, or are now buried beneath a cornfield, a city, or half a mile of younger sediment. A warming climate might stress a population until it collapses. Or it might push that population toward cooler waters, out of the places paleontologists happen to sample. A change in chemistry might make shells thinner, rarer, or less likely to fossilize. Or it might dissolve them before they ever became part of the record. In other words, the same clue can point in more than one direction. And that is extremely inconvenient, which is often how you know science is getting interesting. So the old extinction story did not come from nowhere. It came from a real pattern, a real absence, and a real shift in the rocks. Before the gap, the fossils were visible enough to build a world around them. After the gap, that world seemed to recede into darkness. But as researchers began to look closer, the boundary started to seem less like a clean cliff edge and more like a fog bank. You could still see shapes inside it, just not clearly enough to know what they meant. And that raised a more unsettling possibility. What if the first evidence was never wrong, exactly? What if it was simply incomplete in the most dangerous way, complete enough to suggest a disaster, but incomplete enough to hide the survivors? And then the case gets its first real crack. Not a dramatic one. Not the kind of clue that arrives with lightning, swelling music, and a paleontologist shouting across the quarry, although honestly, paleontology could use more of that. This clue is quieter. It looks like a small fossil in a slab of stone. A hard part. A trace. A piece of an animal that should not be where it is. Imagine a researcher working through a collection, maybe in the field, maybe in the fluorescent stillness of a museum drawer, surrounded by labels written decades earlier. Most of the specimens fit the story everyone already knows. They belong below the boundary, in the world before the supposed disappearance. They are comfortable there. Expected. Almost routine. But then one of them does something fossils are not supposed to do. It shows up later. Higher in the rock. Younger than the version of the story that says its kind should already be gone. And suddenly, this little object is no longer just a fossil. It is an alibi. Because if the extinction had already happened, then this creature should not be leaving evidence after the ending. That is the strange thing about deep time. Sometimes an entire idea can wobble because of one stubborn scrap of shell, bone, or trackway sitting in the wrong place. At first, you might try to explain it away. Maybe the fossil was reworked, eroded from an older layer and redeposited into a younger one, like a page torn from an old book and slipped into a newer chapter. That happens. Rocks are not always polite archivists. Rivers cut into older beds. Storms churn sediment. Currents drag hard parts from one place to another. So the first question becomes, is this really a survivor, or is it just an old clue moved into a younger scene? That is where the surrounding rock starts to matter. The grains around the fossil. The way the fossil sits in the bed. Whether its edges are sharp or worn. Whether other pieces around it tell the same story. If it has been tumbled, broken, polished, and mixed with older debris, then maybe it is a fossil out of place. But if it is nestled cleanly in the sediment, if the layer around it formed after the supposed cutoff, if the dates line up and the geology refuses to cooperate with the old explanation, then the clue becomes much harder to dismiss. And that raises a question that is both simple and deeply annoying. How many more clues like this were missed because nobody expected them to exist? Because expectations matter in science. They do not make scientists careless, exactly, but they do shape what seems surprising. If a group is believed to have vanished at a certain point, then any fossil above that point becomes suspicious by default. Maybe it is contamination. Maybe it is misidentified. Maybe the layer is younger than we thought. Maybe the layer is older than we thought. Maybe the fossil has traveled. All fair possibilities. But each possibility has to be tested. And as more of these awkward clues appear, the case starts to shift. One out-of-place fossil could be a mistake. A handful could be a problem. A pattern could be a completely different story trying to break through the old one. However, this is not just about finding fossils after the supposed ending. It is also about finding the right kind of silence before and after them. Picture a shoreline that once preserved life beautifully, a low, muddy place where bodies could be buried quickly and held in place like evidence sealed in an envelope. Then picture that shoreline changing. The water deepens, or retreats, or becomes more acidic, or shifts into faster currents. The animals may still exist nearby, but the archive has changed its rules. Suddenly, the places that once kept their remains are no longer keeping them. To a creature living through it, this might be a habitat shift. To a fossil hunter millions of years later, it might look like a vanishing act. And here is the uncomfortable part: the first evidence does not prove the old story false right away. It does something more interesting. It makes the old story unstable. It forces every piece of the case to be handled again. The empty layers. The rare late fossils. The sediment. The dating. The possibility of reworking. The possibility of survival. The possibility that the boundary was never a wall, but a blurry zone where biology, geology, and bad preservation all got tangled together. So now the investigation has a new shape. The question is no longer only why the fossils disappear. It is why they disappear in some places, but not quite everywhere. Why the record goes quiet, but not completely mute. Why a supposed ending still leaves behind whispers. And if those whispers are real, if they are not just older fossils washed into younger rocks, then the case has to move in a new direction. Because one survivor after the end is not just a survivor. It is a warning that the ending itself may have been drawn in the wrong place. By now, the case has stopped looking like a simple disappearance, and started looking like a room full of suspects who all have a reason to lie. There is still the old suspect, of course, extinction. Big, dramatic, easy to recognize in a lineup. It has been guilty before. Many times. Earth has a long history of shutting doors on entire branches of life, sometimes slowly, sometimes with the subtlety of a bowling ball through a window. So it makes sense that extinction was brought in first. The fossils faded. The familiar forms became rare. A boundary appeared in the rocks. And when a group that once seemed common stops showing up where you expect it, you do not have to be reckless to wonder whether it is gone. But as the evidence piled up, extinction was no longer the only suspect in the room. Another one sat quietly in the corner: preservation. Less dramatic, but extremely powerful. Preservation does not kill organisms. It just decides which ones get remembered. And it is picky in ways that can completely distort the story. A creature with a thick shell living in soft mud has a much better chance of reaching the fossil record than a soft-bodied animal in fast-moving water. A skeleton buried quickly in low-oxygen sediment may last for hundreds of millions of years. A skeleton left on an exposed shoreline may be scattered by waves, cracked by sun, chewed by scavengers, dissolved by chemistry, and erased before it ever becomes history. Same animal. Different setting. Completely different chance of being found. Then there is another suspect: geography. Imagine an ancient habitat that once lay in the perfect place for fossilization, a broad coastal plain or shallow sea where remains were buried again and again. Now imagine sea level shifting. Not like a bathtub draining in an afternoon, but over thousands or millions of years, with shorelines creeping across continents and then pulling away. The animals may track the moving water. They may follow food, temperature, salinity, or shelter. But the rocks that preserve them may not follow. The fossil record we inherit depends not just on where life was, but on where sediment accumulated, where that sediment survived, and where erosion later sliced it open for us to inspect. Which is a little rude, when you think about it. The planet hides the evidence for millions of years, destroys most of it, and then expects us to be grateful for the scraps. And scientists are grateful. But they also have to be suspicious. Because when fossils disappear from one region, it may mean the organisms vanished. Or it may mean their world moved somewhere the archive did not preserve. Or somewhere paleontologists have not yet looked. And then comes the suspect that might be the trickiest of all: sampling. Not because anyone did anything wrong, but because the fossil record is not evenly explored. Some places have been studied for centuries. Others are covered by forests, farms, cities, ice, oceans, private land, political borders, or just rocks that are not especially friendly to fieldwork. Some formations are famous and heavily collected. Others sit quietly, barely touched, holding clues that do not yet have anyone to recognize them. So if a group disappears from the best-known rocks, that can feel like a global ending. But sometimes it is really a local silence wearing a global costume. That is the mini twist hiding inside this investigation. The first mistake may not have been seeing a pattern. The pattern was real. The mistake may have been trusting the pattern to mean only one thing. A drop in fossils can be a biological signal. It can mean stress, decline, shrinking populations, or a real extinction. But it can also be a geological signal, or a preservation signal, or a collecting signal, or all of them braided together so tightly that pulling one thread does not untangle the knot. This is why the debate gets complicated without becoming any less fascinating. One researcher might look at the sudden absence and see an ecological collapse. Another might look at the same boundary and see a change in sedimentary environments. Another might point to the late fossils, the ones that appear after the supposed ending, and argue that the group survived in refuges, little pockets of habitat where life held on while the main record went quiet. And none of these ideas has to be foolish. That is the uncomfortable beauty of it. In deep time, several explanations can look plausible at once, because the evidence has been filtered through time, pressure, chemistry, erosion, and plain old luck. So the investigation shifts again. It is no longer enough to ask whether fossils are present or absent. scientists have to ask what kind of rocks are present, how old they are, how they formed, whether the fossils are worn or fresh, whether the same disappearance appears in multiple environments, or only in one type of deposit, whether the last fossil of a group is really the last member of that group, or just the last one lucky enough to be buried in the right place. And that question is where the old conclusion begins to feel fragile. Because the final fossil we find is almost never the final individual that lived. It is just the last postcard that made it through the mail. Somewhere beyond it, there may have been survivors leaving no message at all. So the pieces are starting to line up, but not in the way the old story wanted them to. At first, the absence looked like a body outline at a crime scene. Here is where life used to be, and here is where it stopped. But then the question became, stopped where? In the ocean? On the seafloor? Across the whole planet? Or just inside the particular rocks that survived long enough for us to split them open? To answer that, scientists had to stop treating the fossil record like a list of names and start treating it like a landscape. Because every fossil comes from somewhere. Not just a place on a map, but a place inside an ancient environment. A shell in fine mud tells one kind of story. A broken fragment in storm-tossed sand tells another. A fossil in a shallow marine deposit says the animal lived, or at least died, somewhere near that kind of water. But if those deposits disappear from the record, the animals that depended on them may seem to disappear too, even if they simply moved with the habitat. Which raises the next question, what if the boundary was not cutting through biology at all, or not only through biology, but through geography? That is where the rocks begin to answer. Not loudly. Rocks almost never answer loudly. They answer with grain size, mineral layers, ripple marks, chemical traces, and the stubborn geometry of ancient shorelines. A muddy basin may give way to sandier beds. A shallow sea may leave signs that it deepened, retreated, warmed, cooled, lost oxygen, or became less friendly to shells. A coastline that once trapped remains like a net may shift miles away over geological time, leaving behind a record that suddenly becomes much worse at preserving the very creatures scientists are trying to track. So the absence in A leads to the question of the environment around A. And the environment leads to B, the archive itself changed. But if the archive changed, that opens another problem. How do you tell the difference between animals that died out and animals that kept living beyond the reach of preservation? For that, researchers look for survivors in the least convenient places. They compare sites separated by distance. They test ages again. They ask whether the last appearances all cluster at the same moment, which would make a true extinction more likely, or whether they stagger across time and space, like lights going out in different rooms of a house. And that stagger matters. A sudden, synchronized disappearance can point toward a real biological crisis. But a patchy disappearance, one that depends heavily on rock type or region, begins to look suspiciously like a fossil record problem wearing an extinction mask. That is B giving way to a question about B, is the pattern global, or is it an illusion stitched together from local gaps? And then comes C, refuges. Not necessarily lush paradises. More like holdout zones. Places where a group could persist after it had vanished from the best-known rocks. Maybe cooler waters. Maybe deeper basins. Maybe isolated pockets of habitat where the conditions were still good enough for survival but bad enough for fossilization. Picture an ancient population shrinking back from its former range, not exploding into oblivion, but retreating into the margins. In the main record it looks gone. In the living world, it may still be hanging on, scattered, rare, and very hard to catch in stone. That possibility changes the emotional shape of the case. The silence is no longer just ominous. It is evasive. It starts to feel like looking for an animal in a dark forest by checking only the places where the moonlight reaches the ground. If you do not see it there, you cannot immediately say the forest is empty. You can only say the lit places are empty. And now we can return to that original gap with a different set of eyes. The empty layer is still there. The fossils are still rare above it. The pattern that made extinction look so convincing has not magically disappeared. But its meaning has changed. Instead of one clean line between life and death, it might be a messy intersection of shrinking populations, shifting habitats, changing sediment, unlucky preservation, and incomplete sampling. And that is where the missing piece becomes obvious. To overturn the old story, you need more than doubt. You need a way to show that the supposed ending was not an ending everywhere. You need fossils after the boundary that are not reworked. You need rocks that can be dated with enough confidence. You need the geography to make sense. You need the environment to explain why the record went quiet. In other words, you need the survivors to leave behind a clue strong enough to cross-examine the silence. And until that clue is found, the case remains suspended in that strange place science often lives. The old answer is no longer safe, but the new answer has not fully stepped into the light. And then the case turns. Not because the old evidence was fake, or because the scientists who read it were careless, but because the evidence was asked a better question. For a long time, the disappearance had been treated like a biological verdict. The fossils faded out, so the organisms must have faded out with them. Case closed. Roll credits. Maybe at a sad violin over some ancient mud. But once the late clues, the shifting environments, and the uneven archive were all placed on the same table, that verdict started to look less like a final answer and more like an assumption that had been wearing a lab coat. The twist is this: the most important thing that vanished may not have been the organisms themselves. It may have been the conditions that made them visible to us. That is a very different kind of story. In the old version, the fossil gap was a graveyard. In the new version, it may be a blind spot. Imagine a shoreline where generations of animals once lived in water just shallow enough, just muddy enough, just calm enough to turn ordinary death into future evidence. Their shells settled into sediment. Their tracks hardened. Their remains entered the archive. Then the shoreline moved. The mud changed to sand. The basin deepened. Oxygen levels shifted. Currents strengthened. Chemistry became less friendly to preservation. The animals could have declined, sure. They could have become rarer, more scattered, pushed into narrower habitats. But rare is not extinct. Scattered is not extinct. Hard to fossilize is definitely not extinct, although it has caused a lot of trouble for everyone trying to read the past from rocks, which is honestly a very ambitious thing to do in the first place. And that is the reversal. The silence above the boundary does not necessarily record a clean ending. It may record a change in what the rocks were capable of remembering. A supposed extinction can be built from real clues and still tell the wrong story, because clues do not interpret themselves. A missing fossil is not a confession. It is a question mark. And when scientists started treating the gap that way, the whole scene changed. The late fossils were no longer just annoying exceptions to be explained away. They became witnesses. The sediment was no longer just background. It became part of the plot. The geography was no longer a map of where fossils were found. It became a map of where preservation had been possible, where habitats had shifted, and where survivors might have slipped beyond the camera frame. Suddenly, the old suspect, extinction, was still in the room, but it was no longer sitting alone under the spotlight. Preservation was there. Sampling was there. Sea level was there. Habitat change was there. And maybe the real culprit was not one of them, but the way they all overlapped until a messy survival story looked like a neat disappearance. That does not mean nothing happened. This is not the cheerful version where everyone gets out alive and the ancient world was secretly fine. The fossil record may still be showing real stress. Populations may have shrunk. Ecosystems may have changed. Some branches may really have died out while others lingered. The world above the boundary may have been harder, stranger, and less forgiving than the world below it. But the old clean line, the one that seemed to separate existence from extinction, begins to blur. What looked like a guillotine starts to look more like a fog bank. And inside that fog, life may have continued in forms too rare, too displaced, or too poorly preserved for the record to capture clearly. This is the kind of twist that feels small at first, and then keeps getting bigger the longer you sit with it. Because it does not just change one case. It changes the way you look at every apparent disappearance in deep time. When a fossil group drops out of the record, our first instinct is to ask what killed it. But maybe the better first question is more unsettling. How sure are we that it was gone? How sure are we that we are not staring at the edge of our own evidence, and mistaking it for the edge of life itself? That is why this reversal matters. It turns a simple extinction story into a story about uncertainty, survival, and the strange limits of the fossil record. The rocks were not lying. They were doing what rocks do, preserving some things, destroying others, and leaving us to argue over the gaps. The real mistake was thinking that silence had only one meaning. Because in the history of life, silence can mean death. But sometimes, it means the survivors left no easy trace. By this point, the mystery has stopped being just about a missing group of fossils. It has become a much larger investigation into how Earth changes the rules of evidence. Because the more the clues are placed side by side, the less the old ending looks like a single clean event, and the more it looks like a whole system shifting under everyone's feet. The rocks say the environment's changed. The fossils say the familiar organisms became harder to find. The geography suggests the best places for preservation may have moved, shrunk, or disappeared. And the ecology hints that survival, if it happened, may not have looked heroic or dramatic. It may have looked like a retreat. Smaller populations. Narrower ranges. Fewer chances to leave behind anything durable enough to reach us. Picture an ancient coastline again, but now widen the frame. This is not just one beach, one reef, one basin. Across a region, sea levels rise and fall like a slow breath. Warm water spreads into places that used to be cooler. Currents shift. Muddy seafloors become sandy. Sheltered habitats open and close. Some places that once acted like fossil traps stop working. Other places may become livable, but terrible at preserving remains. To the organisms, this is a changing world. To the fossil record, it is a change in visibility. And to scientists millions of years later, it can look like a disappearance so sharp that it practically begs to be called an extinction. But then the evidence begins to converge in a different direction. Not all at once. More like a set of dim lights coming on down a long hallway. A late fossil appears above the supposed boundary, and suddenly the ending is not as final as it seemed. Sediment shows that the local environment changed, and suddenly absence has a geological explanation. Comparisons between sites show that the disappearance is not equally strong everywhere, and suddenly the pattern looks patchy instead of global. The timing starts to matter. The rock type starts to matter. The places where scientists looked, and the places where the right rocks were never exposed, start to matter. And that is when the investigation begins to feel close to breaking open. Because if extinction were the whole story, you would expect the evidence to point toward a broad biological cutoff, a shared moment where the groups simply stopped showing up across environments and regions. But if the record is instead shaped by changing habitats and changing preservation, then the clues should be messier. Last appearances should drift from place to place. Fossils should linger in pockets. The strongest disappearances should line up with the rocks least likely to preserve the organisms in question. And that is exactly the kind of pattern that makes scientists lean closer to the stone and ask whether the boundary is biological, geological, or some uneasy mix of both. This is where the story becomes bigger than one missing lineage. Because Earth does not just decide who survives. It also decides who gets remembered. A mass death can leave a record. A slow ecological squeeze can leave a record. But so can the loss of the right mud, the retreat of the right sea, the chemistry that dissolves shells before they harden into fossils, or the erosion that removes an entire chapter before anyone ever reads it. The planet is not a neutral historian. It is more like an editor with a chainsaw and a very relaxed attitude toward continuity. Which is frustrating, yes, but also the reason the science is so interesting. The truth is not hiding in one spectacular fossil. It is hiding in the overlap between fossils, rocks, environments, and time. The fossil says an organism existed. The sediment says what kind of world could preserve it. The geography says where that world was. The dating says whether the clue belongs before or after the supposed ending. And when those pieces start pointing together, the picture that emerges is not a clean catastrophe. It is a changing Earth that made some lives harder, some habitats rarer, and some evidence almost impossible to find. That does not let survival off the hook either. Holding on in scattered refuges is not the same as thriving. A group can survive a supposed ending and still be in trouble. It can become rare enough that its fossils nearly vanish, while still not being gone. And that is the knife edge this story has been walking all along, between real biological decline and the illusion of total disappearance. The old conclusion may have taken that near silence and turned it into a full stop. The newer reading sees something more complicated, and maybe more honest, a semicolon written in stone. Not the end of the sentence, but a pause so long and so quiet that for a while, it fooled almost everyone. And now the biggest question is no longer whether the rocks were empty. They were, at least in the places people knew best. The question is what kind of emptiness they were showing us. Was it the emptiness after a world had died, or the emptiness left behind when the world moved, the archive changed, and the survivors passed through places that stone was bad at remembering? So where does that leave the case? Not with a neat little bow, because deep time almost never gives us one of those. The better answer is stranger, and probably more useful. The disappearance was real, but its meaning was not as simple as it first looked. Something changed. The old fossil-rich world did not continue unchanged forever. Habitats shifted. Populations may have thinned. Environments that once preserved these organisms stopped doing that job so well. And in some places, the record went quiet enough that extinction looked like the only reasonable conclusion. But the silence was not the whole story. A fossil above the boundary, a changed shoreline, a patchy pattern across sites, a sedimentary environment that no longer kept the right kinds of remains, all of these clues point toward a more complicated truth. The supposed ending may have been less like a door slamming shut and more like a room going dark while something inside was still moving. That is the mind-bending part. In paleontology, disappearance is not a single thing. A species can disappear from one habitat and survive in another. It can disappear from common rocks and persist in rare ones. It can disappear from the places scientists have searched and remain hidden in the places no one has opened yet. It can even disappear from the fossil record long before the last living individual dies. The last fossil is not the last breath. It is just the last breath that happened to leave a mark. And once you see that, the whole history of life starts to feel less like a completed encyclopedia and more like a half-burned map. There are roads drawn in beautiful detail, then sudden blank spaces where the paper is gone. For a long time, it is tempting to look at those blank spaces and imagine cliffs, oceans, dead ends. Sometimes that is exactly what they are. Extinctions are real. Catastrophes are real. Earth has erased lineages with a force that can still be read in ash, chemistry, shattered ecosystems, and the sudden absence of once common forms. But sometimes a blank space is not the edge of the world. Sometimes it is just the edge of the page. And that distinction matters, not only for one ancient case, but for how we read the entire story of evolution. Evolution is not just a parade of creatures appearing and disappearing on cue. It is a messy negotiation between bodies, environments, climate, geography, and chance. It is also filtered through the strange rules of preservation. Hard parts count more than soft ones. Mud remembers better than mountains. A quiet seafloor can become a library. A lively forest can leave almost nothing. The past was not necessarily empty where our evidence is empty. The archive is biased, damaged, and incomplete, and yet it is the archive we have. Which means science has to do something much harder than simply collect clues. It has to learn how to distrust them carefully. Not dismiss them. Not force them into the most dramatic story. But ask what each clue can really say, and what it cannot. That is why these reversals are so important. They do not make paleontology weaker. They make it sharper. A conclusion being revised is not a failure of science. It is science doing the thing that makes it different from myth, letting the evidence reopen the case. And there is something deeply unsettling about that, because the same problem exists all around us. We live in a world changing fast enough that future scientists, if anyone is around to do the work, may read our time through traces we accidentally leave behind: bones, pollen, plastics, soot, carbon in the air, shells thinning in acidifying oceans, species moving into places they did not used to live. They will also have gaps. They will also have silences. And they will have to ask whether those silences mean death, migration, rarity, or simply that the evidence failed to survive. So the old empty layer remains powerful, but now it feels different. It is not just a monument to loss. It is a warning label on the entire fossil record. It says, be careful. The Earth remembers, but not evenly. It preserves, but not fairly. It keeps secrets by accident. And somewhere in the space between a fossil and the absence of one, between a vanished shell and a living survivor that left no trace, history can change shape completely. That is the paradox at the heart of this story. Sometimes the most important clue in the history of life is not a bone, or a tooth, or a footprint. Sometimes it is an empty layer of stone, asking us whether we have found an ending, or only mistaken silence for one.